Hi friends, hope you all are doing well and welcome to EduPole Tutorials. This is our second video of microprocessors and microcontrollers. In the previous video, we studied Introduction to Microprocessor, and in this video, we'll be studying Microprocessor 8085 architecture. So let's get started. In order to make learning easy and riveting, we have adopted a Bluechip way, alias Road to the Architecture. In this, we'll be taking you inside the architecture and will explain you each block in an impressive way. So friends, come on, we are waiting for you. Let's get into the car and start our journey. First of all, we'll take you inside accumulator, an imperative unit. Here, in accumulator, we have placed some racks inside in order to show its resemblance with its functioning. Accumulator is an 8-bit register which is used to store 8-bit data and perform the ALU operations. Now, let's move on to next. Next, we'll take you inside temporary register. Here, in temporary storage, we have placed some shelves inside in order to show its resemblance as well. So, let's get into temporary register. It is also an 8-bit register which holds the temporary data for ALU operations. Now, a very important unit, which is one and only the ALU. So, let's jump into it. Here, for arithmetic logic unit, we have used some arithmetic symbols such as the plus for addition operation, minus for subtraction operations, and multiply and division symbols as well. It performs the arithmetic and logical operations like addition, subtraction, and or etc. on 8-bit data. So, let's turn towards the flag flip-flops. Here, in flag flip-flops, you can see the orientation, the position of the 0, blank, auxiliary carry, blank, parity, blank, and the last, the carry. It is an 8-bit register having 5 1-bit flip-flops, which holds the either 0 or 1. Next unit we are heading to is the interrupt control unit. This unit deals with interrupts. Now friend, come out of the car and see the interrupt control unit and its functioning by the means of bulbs with respect to the each code, line, and how the action of interrupt triggers the glowing of the bulb. It controls the interrupts during a process, and whenever the interrupt occurs, it shifts the control from the main program to the process, the incoming request. And after the request is completed, the control goes back to the main program. After interrupt control unit, the next unit we'll be entering to is in the instruction register. The several instructions such as the data transfer, arithmetic, branching instructions, logical instructions, control instructions are encompassed into it. For instruction register, working is like this. When instruction is fetched from memory, then it is stored in this register only. Next is the instruction decoder and machine encoding unit. Here, the decoding of these takes place and are simplified into the machine cycles such as the opcode fetching and as. Friends, let's ponder on it by means of simplifying a jumbled Rubik's Cube and then unscrambling all its small square block units. All units shows the different machine cycles. It is an 8-bit register. It decodes the information present in the instruction register. Next is timing and control unit. Friend, come out to enjoy the timing and control unit. Here we have used our inquisitive clock and key. Let us get into it and see the timing mechanism via clock and how the controlling is achieved, that presumably by a key. So here you can see that how the key is controlling the timing action. So the timing and control is achieved. This unit basically provides timing and control signals to the microprocessor to perform the operations such as the ready, hold, HLDA, etc. After the timing and control unit, the next unit will be taking you to the serial input-output control unit. So friends, here it is, the serial input-output control unit. Let's get into to see it. By the means of some animation, we have tried to help out in this serial communication within the microprocessor. Here you can see that how a ball acting like a data unit is transferred from SID into microprocessor and from microprocessor to the outer world via SOD. It controls the serial data communication by using SID and SOD pins, serial input data and serial output data pins, respectively. Now the unit is a register collection unit. Various registers and that is stack pointer, program counter and latch as well. Friends, let's transfer ourselves. Let's fasten ourselves as we are heading towards the end of the journey. Again came the rack structure. There are 6 general purpose registers, that is the B, C, D, E, H and L, and 2 special purpose registers SP as well. Now let's head downwards and come out to see the next unit. After this, the address buffer. Address buffer is collection of various address lines from A8 to A15. The content stored in stack pointer and program counter into the address buffer to communicate with the CPU. And now, the last unit is the address data buffer. Address data buffer comprises of various multiplexed lines starting from AD0 to AD7. So here you can see the various lines AD0, AD1, AD2, AD3, AD4, AD5, AD6 and the last one, the AD7. The memory and I/O chips are connected to these buses. The CPU can exchange the desired data with the memory and I/O chips. Now friends, as the last stage of our journey, we are presenting in front of you all the alignment of all the roads as buses and positioning of the various blocks in the architecture, which we have learned so far, and also their proper interconnection with the buses. Hope you all have enjoyed this journey, the road to the architecture. I believe this tutorial helped you, and please don't forget to hit the like button and do subscribe to get the notification for the subsequent videos. And if you are having any queries, feel free to write in the comment section. And also you can refer to the notes provided along with on the link below. Thank you very much.